Consulting Technical Saif. Today we are going to learn how to design a standalone system on PVSyst software. There are different versions of PVSyst softwares, which include 6.8 and 7.1. Mostly the interface of both the softwares are a little bit different, but the functions of both these softwares are equally. I have a licensed versions of 6.8, and that's why I'm going to prefer 6.8. It depends on your case what you are prefer. Okay, our further steps are going to be run on 6.8 version. When you open your PVSyst software, it looks like this type of interface. Here the first one is preliminary design, the second is project design, then database and the tools. We are going to a standalone project design. I have clicked to project design. In project design there are further 4 main layouts over there. You will going to be select standalone system. Actually I have already a one license to create over there, that's why it's showing. Now we are going here to create a new project. We are working for it. By creating a new project, the project is the file that contains essential information for your system. This includes the location, the reference to its meteorological data file, and the general information related to your project. Here we type a name for our project. It's going to be lesson number 2. The same name I will be copy from here and paste at the attribute project name. It's lesson 2. Alright, now you can select a geography for your project area. The project geography you will select here, click new site. From here you can select your project geographical area. Here click on it and type a name for your project site, lesson number 2. I will type lesson number 2 here. Then from here you will select your country. I am from Pakistan, I will select Pakistan, and it's the region also depend on the region where you working or operate your project site. Now you can put a geographical coordinates. For suppose if you have not a geographical coordinates, it's very simple to know your geographical coordinate system. You will open Google Earth, from where you search your project site. I have searched Islamabad, Pakistan. Alright, I will search here my project site. Alright, okay, I will select it's the field. I'm going to install my project site in this location. Okay, I will create a pin. Now I will drop a pin into the center of my project site, from where you copy a lat and long. First you copy a lat and paste over there, and now you can copy a longitude and paste in longitude box. You see here it's automatically convert the decimal degree to degree minute seconds. It's not required to put these coordinates in a degree minute second. You will put in a decimal degree in a first row. Here you will find altitude, mean above sea level. You can go here and you watch here, you see here it's your altitude. You will drop a pin and find what's the altitude. It's a 525 meter. I will put here on my software, that is 525 meter above sea level. Here I will put a time zone. It depends on your location. I am operating from Pakistan, Islamabad. That's my time zone is 5. It depends on your zone. You will set accordingly. Now from here you will select metronome data import. There are different databases are available there. Mostly we are run our PVSyst simulations on metronome 7.2. Here you will click on it and click import bar. You will just wait a little bit. Now it will be defined the major data of your site is our capturing over there. Then it's kilowatt hour per meter square per month. You can click OK and you will save your metronome data. Okay. After it you will click on yes and again save. Your geographical sites are also be done. Now you can going to save your project with the new geographical site and click save. Now the first step of your project standalone system design is done, where you give a name for your project. You will select a project geographical site of your project area. Here there are two pop-ups show in red color. That was the orientation, and the next one is user needs. Here you will set orientation of your panel. It's also depend on the literature. You will may read literature and study literature of your project site. It must be accordingly. It will be vary from location to location and country to country. You will be changed, and the plan tilt and the smooth will also be matter over the location. It will be changing with locations. Alright, I will set my plan till this 25 and click on yearly irradiation yield. Not going for the winter or summer, so you will here click the yearly irradiation yield. Alright, now click OK. And the second thing, the first component of the element you have done. The first component of the element you will done. Now you are starting with the second component, that is user needs. What are the user needs actually? You will starting with, first suppose you have to create a standalone system for a building. You will select the main appliances of that building. I will select here. First suppose we have 950 lamps. The voltage, the power of all these lamps is going to be selected per lamp is 120 watt. Now the second thing is TV. It's going to be 185. The power of these appliances is around 150. I will assume that it's on your case. If you are going for a practically applied, you will must follow what the actual voltage is, what the actual appliances in your system. You will plan accordingly. Okay. Now the next things are domestic appliances. Like other things, we have going to be 100 domestic appliances. The power of domestic appliances I am going for the 350 power. Alright, and the next thing is going to be a dish and cloth washer. It's, I assume that 100, and the power of each is 320. Alright, now we have done all these steps. Now we have all the distributions of all these appliances. When it uses the uses of the appliances, you will may select from over there. Okay, first suppose we have limits using from here to onward. I just assume that you will put according to your actual case where you are designed for, right? It's going to be 18 hours. Now the TV and the PC mobiles I'm going to be assume is for a 24 hour. Okay, you will click and hold your mouse button and you will move cursorily. And next thing I'm going to be domestic appliances we using from it's up to 3 or 2 going up to it's for around 12. Alright, alright, rest is going to in this interval of the day. Okay, now the dishcloths we are using, click here or there, and sometime we using or sometime we using or there around this time, and we have select different scenarios. It's for just for learning purpose. I have supposed all these timings for learning purpose for different scenarios. Then click OK. Now your systems will be going to be finalized here. Alright, and then click OK. Your user needs will also be defined. Now you're going to be system design. Before your system design, you will be click here and lithium ion battery. It's some sort of 25. It's going to be please choose module. Alright, you will choose the battery over there. Then PV module, you will be going to be click here. It's up to your 115, 120 or 110 Saif poly. It's up to you what are going to be select for your system. Alright, please choose the controller model or operating system. It's going to be MPT2 mode. Alright, the system is going to be designed around 984 kilowatt. You will see it there. The appliances you will choose, the load of all the appliances is around 1 megawatt. It's 984 kilowatt. To manage this power, you will watch over the STC power over there. You will increase some power over there. Alright, it's a little bit more. Okay, you will be click it's somehow close to your system and the appliances need. It's system okay for your system. I will just going to be run for a learning purpose. It's going to be 942, but in your case, if you are going to be actual design for your system, then you will must mesh for the need of the appliances power and the actual STC value. You will be equal or somehow it will be bit more than the actual appliances need. Alright, you will click OK. Now the system is also will done. Now detail losses I will going to be a free mounted modules. Now it's going to be 29 watt per meter square K. And the second is ohmic losses. It's automatically selected. The module quality, it's also from your module data sheet. You will put over there manually, but it's going to be automatically. It's what be done for you, but it's not be a very major variations in your report. The soil loss it depends also for your geographic site, but mostly we have as a thumb rule we use a 2% of soil losses we add on it. Otherwise, if you have a clear project site, then there is no any polluted atmosphere, then I think it will be going to be over there. IM losses also there, spectral corrections. Now okay, the detail loss is also done. The horizon Horizon also matters when you select the geographical site. The horizon automatically capture over there. Now if you have changed the horizon of your sun rotation, it mostly not for specific regions where the normally the sunshine over there, but it can in cases of such side of a North Pole region, you will not will happen with it. You will not further changing on it, not required. You just pause on it. Okay. Then your shading, you will the near shading is also it's a major component of your report. When you going to construct your shadings analysis, you will select over there and create. It's going for the PV panel. Alright, PV table shade. Click here. Now you can be check from over there. The pitch you must be select for your system design. The number of shades, it's going up to be 9 or 10. It's depend on the space of your project area. Now the another thing is PV by modules. It's you are going to orientation your module like in a portrait mode or a landscape. It's also up to you. You will select, and in number of modules in x-axis and y-axis. In x-axis we have select 5, in y-axis I select going to be 2. It's up to on your scenario. You are plan accordingly. Alright, adjust modules, you click here and then click cancel and click yes. Now you watch over there, the modules are selected over there. Now it's a simple way. You can just control copy and control paste, click on it and modify. You will be move on it. You will select again copy and paste. You will plan accordingly. I will just mute a video over there, and after once I will clear the shading construction, continue the video. Okay, now you will further control copy and control paste over there. Okay, modify. You will move and set accordingly. Okay, now check it. It's done now. Then you will complete your you will compute your shading table. Now it's done. Okay, your all parameters and elements are going to be done. Now you are going to run simulation. Once simulation is done, you will be new variant. Yes, you are going to be a new simulation variant. Description, it's lesson number 2. Write the variant name over there and save. Now you will see the report. The report is done. You will wait just a little bit to saving the report in a document form. Okay, the report is done. You will see your report, standalone system simulation parameters, project lesson number 2, geographical site further, the major standalone system with batteries, the PV array characteristics over there, the PV simulation table. It's a shading analysis also be done over there. When you're going to be designed for a rooftop, then you will be going for creating a 3D building design. After it, then you will be adjust the panels on the roof of that 3D building design. In future tutorials I will also be working on it. You will be keep in touch. I will further details about the standalone system design user needs, the actual hardly profile of the area. Now the major standalone system main results: the near shadings, the linear shadings, the available energy kilowatt hour per yearly is calculated, where software is calculated. It's the balance and demand results sheet over there. This is daily input output diagram. That's pretty good. And this is the final loss diagram over the whole year. What is the total number of soiling loss factor, the shading, all the effective energy to the output of the array, and the energy need of the user load. Okay, the system is done over there. Thank you for watching. Keep in touch. We are working in future for more other system designs, which include pumping and also some other projects including DC grid also. In future I will also working on a detailed shading analysis and the how to we import R&D files. We are also working on that. Alright, thank you so much for watching this video. Subscribe my channel to get more informative videos.